Hi, in this new chapter, we will discuss about 802.11 MAC architecture. For that, we should know that wireless operates in layer 2, that is the data link layer. Okay, data link layer, which means any traffic coming from layer 3 to 7 will fall on layer 2 and then be processed accordingly. So, data link layer is divided into two sublayers. One is LLC, that is logical link control, and the other is the MAC sublayer, which is media access control, right? So now what happens is whenever the traffic or whenever the data falls from layer 3 to 7, it falls on the LLC first. Okay, now we have something called the MSDU, which is also called as MAC service data unit, which is from the MAC sublayer. MAC service data unit, MSDU, is equivalent to the LLC information plus whatever is coming from layer 3 to 7. This is called the MSDU, which is also LLC plus now coming from layer 3 to 7, it is, we can call it the IP packet. Okay, now MSDU is also known as the data payload on Wi-Fi. Equal to MSDU, which is equal to LLC plus the IP packet information. So whenever we talk about the data payload, we are talking about the MSDU. Always remember that. Right? Okay. So once the MSDU is created, it falls onto the MAC sublayer. The moment it falls onto the MAC sublayer, it becomes the MPDU, which is the MAC protocol data unit. MAC protocol data unit, which is nothing but MPDU is nothing but MSDU, which we got from LLC, plus the header, MAC header, that is created or that is put on the MAC sublayer, plus a trailer, that is FCS for CRC, right? Now this MPDU that we have created here is a complete 802.11 frame. So whenever we talk about a payload, data payload, it is MSDU. Whenever we talk about a .11 frame, we call it as MPDU. Okay. Now, as per the Wi-Fi standards, 802.11 standards, the size of the MSDU can go up to 2304 bytes. Not 1500 bytes as in wired. In Wi-Fi, we allow size of up to 2304 bytes. Plus, of course, the overhead for the encryption that's added to that. But an MSDU size without encryption can be of 2304 bytes. Right? Now, this happened on layer 2. Okay. Once the MPDU is created and handed off to the physical layer. Now the physical layer also is divided into two sublayers. Okay. One is the PLCP and the other is the PMD. We need not know the full forms, but just to be sure, I'll tell you the full forms. That's physical layer convergence procedure, that is the upper part, and physical medium dependent sublayer is the second sublayer in the physical layer. So this is layer 1. Now, when the MPDU is created as a wireless frame and falls onto the PLCP, it is called a PSDU. So literally, PSDU is equivalent to an MPDU. Absolutely same. It's just that on the physical layer we call it an PSDU, but on the data link layer we call it the MPDU. So PSDU is what is created when MPDU falls onto the PLCP. PLCP will do nothing but add a preamble and the physical header. Okay, so on the PSDU, when we add the physical layer header and the preamble, we get something called the PPDU. Preamble is used to synchronize the bits for transmitting and receiving at the transmitter and the receiver. Once the PPDU is created, it is handed off to the PMD. PPDU goes to the PMD. From there, it modulates the bits and begins the transmitting of bits. So that's how this whole process happens. When the traffic falls or when the data comes from layer 3 to 7, the IP packet, it falls on the LLC and becomes the MSDU. That's the payload, data payload, MSDU. MSDU goes to the MAC sublayer and a MAC header and the FCS gets added. It becomes a .11 frame, which is the MPDU. MPDU falls on the physical layer and is equivalent to the PSDU because it is seen from the physical layer side. PSDU becomes PPDU when we add a physical header and a preamble to it. Now, once PPDU is created, that is the end product. PPDU is handed off to the next sublayer of physical layer, which is called PMD. And then from PMD, it is transmitted onto the medium and goes out. That is the entire process of transmission and receiving of the frame. So there are a lot of details available on preambles. We won't be covering those details in this particular course, but there are a lot of different types of preambles which are available in .11n protocol, .11ac protocol, which is worth a read. If you're interested, by all means go ahead and read about it, but for this course we're going to stick to this for now.